Hi folks, and welcome back to Math with Captain Rod. The purpose of this video is to demonstrate how to integrate with functions that end up with logarithmic type of answers. So the first one we're going to look at here is the integral minus 1 to 0 of 3dx over 3x minus 2. And in order to work this integral, what I'm going to do here is I'm going to make a kind of a standard algebraic substitution here. You'll notice that we get this 3x minus 2 in the bottom. And you'll notice that if I differentiated this, the derivative of 3x minus 2 is 3. So what I'm going to do here is I'm going to make the following substitution. I'm going to let u equal 3x minus 2. Now, when you make an algebraic substitution, my advice is, especially if you have limits, is follow through and completely change everything, limits included. So if u is equal to 3x minus 2, then du is going to equal 3dx. That's because du dx would equal 3. And I'm also going to take a look at the limits here. If x is equal to negative 1, then u is equal to negative 5. And I'm getting that by taking the negative 1, putting it into my algebraic substitution here. If I put a negative 1 right here, we'd have minus 3 minus 2, and there's your minus 5. If x is equal to 0, that's my top limit, and I put that into my algebraic substitution here, u is going to equal negative 2. So what we can do now is completely rewrite this integral as the integral from, instead of negative 1 to 0, it's going to run negative 5 to negative 2. Okay, and the top of this thing is 3 times dx. Now, to get the dx, I'm going to look right here. Dx is equal to du over 3. And in the bottom of this thing, 3x minus 2 is equal to u. So here's our new integral transformed into something quite a bit simpler. All right, so I notice that these 3's will cancel. I'm just going to rewrite the integral again. So now we've got the integral minus 5 to minus 2 of du over u. And now I'll just take use of the fact that we know that the derivative of ln of x is 1 over x, which means the integral of 1 over x is ln of x. So this is equal to ln of u evaluated from minus 5 to minus 2. So this is going to equal ln of minus 2 minus ln of minus 5. And by properties of logarithms, this can be written as the natural log of negative 2 over negative 5, or natural log of 2/5. So there's an example of how to integrate functions involving logarithms. I think what I'll do here is I'm going to go ahead and write another example. I think I'll just pause this while I do that. All right, folks, so I'm back. Got a second example I'll take a look at here. So what we're going to work through here now is the integral from 2 to 4 of dx over x ln x. You know, one thing to take note of right away, we've got this ln x sitting in the bottom. And also keep in mind that, you know, if y is equal to ln x, then y prime is 1 over x. And I'll notice I've got effectively 1 over x sitting here. So this gives me my clue as to what type of substitution to use in this problem. I'm going to go ahead and let u equal ln x. Okay. Du would then be 1 over x, and I'm noticing I've got a 1 over x right here. Whoops, 1 over x dx. Okay, and 1 over x dx, that's basically sitting right here. I'm going to go ahead now and change the limits. If x is equal to 2, then u would equal, and I'm going to take this bottom limit 2 and just sub it right into my substitution here, ln of x, ln of 2. And then if x is equal to 4, u is going to equal ln of 4. Again, that's coming from this algebraic substitution. So what we can do now is completely rewrite this integral. And the new integral is going to run from ln2 to ln4. Right now, let's see, dx I'm going to get from right here. Dx is equal to x du over x, that's that guy, and then natural log of x is equal to u. And you notice our x's cancel. Right. So now what we have is just the integral of du over u, which is natural log u. So this is going to equal natural log u evaluated from natural log 2 to natural log 4. So what we end up with here, it looks like it's natural log of natural log 4 minus natural log of natural log 2. And by rules of logarithms, we can combine these into one log. So this is equal to natural log of natural log 4 over natural log 2. Now, I'm going to go ahead and just move on and look at another example. This could conceivably be simplified into something else, but suffice to say this is some number. Natural log of 4 is some value, natural log of 2 is some value, and the ratio is some number of which we can take a logarithm of. So I'm going to go ahead and stop that right there and look at some other examples.